This part of the presentation is really about some of the city networks that we've been working on, and optimising city networks and what we learned from that. Obviously, there's an awful lot of work involved. It was fairly new to us as well. Individual optimisation is, I suppose, our bread and butter, but to do a city, to look at the whole city as one complete system is a lot harder, and there's a lot more to think about. So the optimisations that we've done were for Southampton and for Birmingham. We worked on 5 key properties within each city. We're talking about hotels, we're talking about libraries, civic centre, that sort of thing. So some fairly big users of the system. But it wasn't just commercial, there were also domestic blocks as well. So tower blocks full of domestic properties with HIUs running. So quite a big system there. But we took a fairly broad spectrum of properties across each city. Types of heat networks, as I mentioned, were residential, so with HIUs, commercial and retail buildings, so shops, hotels, that sort of thing. Council buildings, these were probably the most fun part, actually. I think some of the things we saw in the council buildings was quite an eye-opener, but also, as you'll see in some of the photos, a real sort of look back at what they used to do years ago, and what is still running, actually, and the quality of the kit that was installed at the time many years ago. Obviously, you've also got in these cities hospitals, libraries and schools, so they're all connected to the same heat network. So the areas that we investigated were the fault detection of the systems and any reporting that was involved in the system. The secondary system KPIs, so what's the system supposed to do? How's it supposed to deliver heat to the end client? Every client has got a different need for the heat. If it's domestic, then obviously you're looking at HIUs. If it's a library, they've got to try and keep the heat within certain parameters to make sure they don't get too much humidity and that sort of thing. So every different connection to the network has got a different way of using the heat that's being delivered to it. Some people are asking for water at 100 degrees or 105 degrees C. Some people want it at 70 degrees C. How do you do that when you're all connected to a same network? So it's interesting looking at the secondary systems and the KPIs that are in place for that. We then looked at substation operation. Are the substations working? Are they doing what the client need them to do? Are they doing what the energy provider need them to do? That's your interface. That's the point where the two systems cross over. So you've got to have something in place that makes sure that you're getting everyone in the process is happy with what's happening on the substation. So again, it's a key area in the system. We looked at return temperatures and bypass flows. Obviously, there is significant problems with bypass flows in systems because you're just chucking away heat back into the heat source. So it's not ideal to have that. We also looked at water quality, and again, something that is key to these systems when you're running plate heat exchangers, for instance. Water quality is key, but also in the pipework as well. If you've got bad water quality, you get sediment build up. And then the pipes start to have problems. So water quality can cause components to fail, seals to go, that sort of thing, and it's never a good place to be when you've got bad water quality. We looked at direct and indirect connections. So I mentioned plate heat exchangers, but we also had systems where the network was being plumbed straight into a building and then sent off around the building. So interesting studies that we've done there. Heating and cooling systems, Richard touched on it earlier with some of the systems there. We were looking at whether there's an overlap. Is the heating being turned on because the system's too cold? So why is the system too cold? Do you need to turn the cooling off first and see if it equalises itself? So that overlap can be very expensive. Domestic hot water generation and storage. Again, Richard touched on it earlier. Our background with thermal stores and designing systems where we can store hot water enabled us to really look at these systems and understand what they were doing, why they were doing it, and how they can do it better. And then finally, the BMS quality. We've seen everything from really good quality systems where you've got all the licensing in place, you've got all the data points available to you. Everything's fantastic, and then we've seen systems where they've got a BMS and they can't even log into the computer to look at the BMS. So these systems are, they've spent tens, if not hundreds of thousands of pounds on a BMS system, and it's sitting there on a computer that no one can even log into. So it's a massive waste of money. This is an example of the Civic Centre in Southampton, and you can see, we've got a fairly ageing plant room, but I tell you what, this stuff was working, and it's working really, really well. It's Bakelite controls and switches, that sort of thing. If it's working, great, then why rip it out and start again? Why put in tens of thousands of pounds more controls? Let's have a look at what we can extract from this information, or from this piece of kit. But yeah, as you can see, I mean, it's a proper relic, but it's lovely to see. The issue with these systems, though, is I suppose lack of funding. This is a government building, so it's had lack of funding, lack of maintenance. Some of the readings are inaccurate, so is the BMS trying to work with inaccurate readings? Well, that's not going to do anyone any good. And then the next problem really was lack of documentation. This was built ages ago by companies that don't exist anymore. So where's the documentation that relates to it? Who's got that documentation? Has it disappeared? Has it been shredded? Where has it gone? We found one drawing of the Civic Centre installation, and this was provided to us by a gentleman who is about to retire. He'd done this drawing about 20 years ago to try and understand himself what was going on with the system. This is the only working drawing of that system. So this lack of as-installed drawings is a huge problem, and we see it across most sites. It's either no drawings at all, or you look at the drawings and they're completely wrong. Someone's modified the system, never allowed for updating the drawings. That's very hard to work with as an energy provider, so you've got to try and get the documentation as accurate as you possibly can. We're also seeing, of course, the gentleman who provided this, he's going to retire. Where does that information go? Sometimes these people leave the company and they don't pass on the information that they've got, so that gets lost, and then suddenly you're left with a system and no one knows what on earth's going on with it. There's also a lot of systems out there with what we'd call unknown inaccuracies. So, to the average person, you'd look at this and say, okay, well, we've got some decent temperatures there coming out of the plate heat exchangers. The clarifiers are sitting there at 60 odd degrees. That's all looking good. We looked at it and said, hang on a second, where's that 21.6 degrees coming from at the bottom there? We went around, we found the sensor that was giving us that reading, and it was hanging in open air. It wasn't even connected to the pipe. So someone in all this time, and the BMS system's looking at this saying, well, that's the temperature, it must be correct. But only by looking at it and studying it in some detail did we find that there were problems. But this is a typical system. You've got some errors on there. You've got valve positions. The nearest valve to me, down here, 100%. The valve on the opposite side of the system is at 3%. Why is there a difference? Why are them valves fully open? No valve should ever be fully open. It should always be modulating into a mid-position at the very most. So everyone thinks the information's correct, but there's inaccuracies in the information that people don't pick up on until you start putting monitoring in there, and then you can suddenly see this stuff jumping out at you. This is another BMS download that we've done on the system. We said to the guys, okay, what speed are the fans running at? Well, they're on. That's what we were told. The fans are on. And we said, well, how fast are they running? Well, we don't have that feedback coming back to us. Why would we need that? So we said, well, surely you need to have more accurate detail coming through to you to understand what's going on with the system. This particular system, again, there was an overlap with heating and cooling. So, it's an air handling unit. We had heating turning on the same time as the cooling, so we were fighting constantly trying to get the system up to the right temperature. The feedback from these systems is really, really important. So and it needs to be detailed feedback. It can't just be a case of it's on or off. It needs to be, we need the pump speed, we need the fan speeds, we need to understand what's happening there. So we go into these systems, we fit our monitoring kit. You can see it in the grey box in the bottom right corner there. We've also fitted on this particular system a clamp-on heat meter. That enables us to take as much information as we can from the system. We feed all that back through into our monitoring equipment, together with a bunch of sensors. They might be clamp-on sensors, or we might connect to existing sensors that are already in the system. But we feed everything back to our monitoring system, and this enables us to start reading what's going on. Here you can see two different systems. The one on the right is a direct system. So this is big pipes coming into a property and being fed straight through the property. This is a big retail outlet. On the left-hand side, we've then got a hotel system, and this is an indirect system. So again, you know, our monitoring can go into any different type of system that you can imagine. If there's not a heat meter there, we'll fit a heat meter as part of what we're doing, because that gives us a huge amount of information. If we're unable to put sensors onto pipes and wire them back to our control box, then we'll use wireless sensors. We've got a supplier that gives us a really good quality wireless sensor, and we can strap that onto the pipework, and then that will talk wirelessly back to our box. So we're not limited by the plant room and by the access for cables and that sort of thing. We can do everything wirelessly if we need to. So in terms of the data analysis, we're obviously using the meter data. Sometimes the meter data is a little bit too much. Sometimes there's gaps in it. Sometimes the information's not entirely clear. Often it contains a huge amount of unwanted information. So we have to sanitize the heat meter data, and that comes into our system. We look at the key parts of that data, and then we sanitize it to show what we need to show. Obviously, we've got the sensor data. That might be temperature, it might be pressure, it might be flow rate, that sort of thing. We've got the exported BMS data, which is data that we can literally export straight from the BMS into our system. So why not use all of the sensors that are already installed on a network instead of installing new sensors? We also use degree day weather data. So around the UK there is a degree day weather data website that takes every different area in the UK, and you can actually look at what the average weather data has been over the course of the last few years in that particular area. So we use that to our advantage, and we can actually then feed that into our monitoring system as well. Photographs and site records, as we mentioned earlier. We also look at contracts. Contracts are actually quite important with these systems, because some systems haven't got any contracts in place. Some have got contracts that are meaningless. Some have got contracts that tie down one party or the other. Steve touched on it earlier. You know, there's a huge amount of stuff to consider with contracts. You've got to think about you know, not only the energy provider, but the client, the end users, that sort of things. And you've got to make sure that the contract is acceptable to everybody. And then finally, we look at the operational requirements. So in Southampton, for instance, they've got a geothermal well. They want to make sure that geothermal well is working correctly. They want to make sure that it's getting the right temperatures returned to it from the system. If the system isn't running efficiently, then the geothermal well isn't running efficiently. So obviously that's a key aspect to this system. It's got to run efficiently. It's a huge investment. So is that, you know, is there a geothermal well? Is there a CHP going into the system? Whatever it is, we have to look at that in detail to make sure that if and when it's integrated, that it's going to work correctly. In terms of reporting, we wrote huge detailed reports, 120 pages for each of the cities. We report on all the problems we've found. We look at the specification for the client. So, you know, what does the client actually need? The people operating the BMS, have they got the right connectivity? Have they got the right quality assurance and loads on the system? We look at the specification for the substation. for any upgrades that are required on the substation to improve the efficiency. Specifications for domestic hot water systems and the replacements if need be. Some of them are oversized, some of them are undersized, some have got pumps that are running flat out. We need to address all of that side of things. Then we look at the operational KPIs for both the client and the operator. Let's get this balance, let's make sure everybody's happy. Let's make sure that if the energy provider needs a 60-degree return temperature, that they're getting that. They're not getting 70 or 80 degrees from one particular property. Something that's fairly new, I suppose, to the industry, which is should be there in the first place, but it's not. It's the procedural documentation, the strategy, how things are supposed to be done. This is all part of this handing over of information in the future. So, if people leave the company, if they leave the organisation, there needs to be set procedures, set documentation that actually explains how this is working, why it's doing what it's doing, and the strategy behind that. And then finally, we like to try and train the people in the strategy. Let's not just come along, do it and walk away and say, there you go, that's working for you. Let's tell them why it's doing what it's doing. Let's train these people up. Let's give them some sort of ownership of it, really, so that they can look at it in the future and say, this is or isn't working correctly. So really the key learnings are that BMS systems don't necessarily efficiently control the system. Sometimes they hide the inefficiencies. Sometimes they're untrustworthy. Some BMSs you can't even see, so why would you believe what you're seeing, what you can get from it? Many commercial buildings lack technical knowledge. We've had head of service and maintenance for a big commercial building come in and say, yeah, I've opened all them valves and it seems to work okay-ish. And we look at it and he's opened every bypass around the whole system. And you think, this is a qualified engineer that's doing this sort of thing. So problems are often managed by third-party companies, and them third-party companies aren't necessarily either empowered or interested in managing it properly. So you've got to be careful with that. Poor knowledge often leads to replacement of old systems. This is a big bugbear for us. We're all supposed to be environmentally friendly. We're trying to look at net zero. Why are we going to rip out a perfectly good system and stick something else in there? Let's have a look at the system. Let's see if actually what was designed 10 years ago can be made to work efficiently. Putting in like for like is all very well and good as long as it works. But if like for like, if the original didn't work, why would you put it in again? But we see this on a regular basis. There are some exemplary clients that we've come across, some companies that really are doing this well. I love this line. Richard actually came up with this line: most require a stick rather than a carrot to achieve the efficient operation. And that's absolutely right. You go in there and you talk to these people and they're not interested. They say, I'm just doing what head office have told me to do. There's no money available, blah, blah, blah. Well, let's talk about how we can save you enough money to then invest and start saving more money. And finally, it's a horrible point to make really, but some people just don't want to be helped. Some people really aren't interested because it means they've got to stand there, hold their hand in the air and tell their boss that they've been doing it wrong. And it might have been for a long, long time. There might have been an awful lot of cost involved in some of the mistakes they've made as a professional. So they won't admit to it. They won't stand there and hold their hand in the air. What we try to say to them is, try and flip it on its head. Try and go with a positive message to your boss. Tell your boss you're doing something about it. Tell them that you're going to save them money. You're putting something in place that can help them understand why these losses have been in there in the first place. That's going to work an awful lot better for you. Okay, so that's me finished.